Hello everybody, myself Bonnie Isaac. Today, me and my friends are going to conduct a presentation in the topic alloy steel. So what is alloy steel? Alloy steel is a steel that is alloyed with a variety of elements. Its total amount between 1 to 50% base weight to improve the mechanical properties of stainless steel. So by adding one or more elements, obtain positive effects for the stainless steel. The commonly added alloy elements are manganese, molybdenum, nickel, chromium, vanadium, tungsten, cobalt, silicon, copper, lead, titanium, sulfur, phosphorus, aluminum, and boron. And the presence of these alloy elements led to the improvement in properties of carbon steel. Now let's discuss each important alloy elements and their functions one by one. First one is manganese. Manganese serves as an important alloying element. Many different types of manganese alloys are available in the market today, including ferro-manganese alloy, copper-manganese alloy, high-manganese alloy, and nickel-manganese alloy, to name a few. Manganese is normally present in all steel and functions as a dioxidizer. Small addition of manganese are used to dioxidize the alloy and enhance its mechanical strength and capability. It's usually seen between a range of 0.5 to 2%, and the main other functions are increase the hardenability, reduce adverse effects of sulfur, etc. Now let's see how it's performed. In antimony and aluminium, the addition of manganese produces highly ferromagnetic compound, and in steel, manganese enhance strength, stiffness, hardness, toughness, hardenability, wear resistance, as well as fogging and rolling qualities. The second one is molybdenum. It is relatively expensive alloying element and at corrosion resistant and high temperature strength. Molybdenum primarily increase the corrosion resistance of stainless steel and generally improve the hardenability and eliminate temper brittleness in steel. It can be usually seen in a range between 0.1 to 0.4%. The important functions are improve hardenability, enhance defense of other alloy elements, eliminate temper brittleness, improve the red hardness and wear resistance, etc. And as a large atom, molybdenum increase the elevated temperature strength of stainless steel through solid solution hardening. And this technique is used in heat exchangers and other elevated temperature equipment such as automotive exhaust systems. The third alloying element is nickel. And as an alloy element, nickel enhances its important properties such as formability, weldability, and ductility, which increase corrosion resistance in certain applications. And so also increase the impact resistance at low temperature. It can be seen between a range of 1 to 5%, and nickel is added above 8%, which imparts the corrosion resistance. The important functions of nickel in alloys as an alloy steels are increase the toughness, increase impact strength at low temperature, etc. The rest of the topic is taken by Bastin. Thank you.
Alloy elements are chromium, vanadium, tungsten. So first consider chromium. Chromium is a chemical element with the symbol Cr and atomic number 24. It is an element of group 6 according to modern periodic table. It is a steely grey lustrous hard metal. It is very less expensive and the most common alloying elements in steel. They were usually added in the range of 0.5 to 4%. It form carbides having high hardness and wear resistance. The presence of chromium helped to increase hardenability, strength, and wear resistance of steels. They were added to tool steels, structural steels, and stainless steel. In stainless steel, 12% or more chromium is added. High temperature properties and corrosion resistance are greatly improved when chromium is added excess of 5%. They were added to steel to increase resistance to oxidation. This resistance increase as more chromium is added. In stainless steel, they have a minimum of 10.5% chromium. Chromium help it improve corrosion and heat resistance, increase the depth of hardening during heat treatment, and high temperature strength. In high-speed steel, chromium plays an important role in hardening mechanism and is considered irreplaceable. The practical applications are they were used on cars, bicycle, and to produce a smooth silver finish that is highly resistant to corrosion. Next alloying element is vanadium. Vanadium is a chemical element with the symbol V, atomic number 23. It is a hard silvery gray malleable transition metal. This element is found rarely in nature. It is a powerful deoxidizer and a strong carbide former, and it helps to prevent grain growth. Though it is an expensive element, it helps to increase hardenability, elastic limit, wear, and fatigue resistance. They were usually added to tool steel in the range of 0.1 to 0.3%. A small percentage of this vanadium helped to increase the elastic limit of steel considerably. 80% of this vanadium produced is used as a steel additive. These steel alloys are very tough and are used to make armor plate, axle, tool, etc. Less than 1% of this vanadium and a little chromium make shock resistant and vibration resistant. Vanadium has been a micro-alloying element for steel products. These vanadium, chromium, titanium alloys help to resist swelling and maintain ductility under a high neutron flux. Vanadium and NB alloys are less dense than other refractory alloys and ductile even with the strength up to 160 KSI. Next alloying element is tungsten. Tungsten is a chemical element with the symbol W, atomic number 74. It is a rare found element found naturally on Earth. They are combined with other elements in chemical compound rather than alone. It is a strong carbide promoter and forms hard stable carbide which impart excellent wear resistant hardness to steel. It performs similar function as that of molybdenum. It is an expensive alloy element like a molybdenum. It is used in the range of 2 to 3% and added to tool steel and heat resisting steel. Some of the practical applications are they were used in electrodes, heating elements, field emitters, and filaments in light bulbs and cathode ray tubes. They are also used in heavy metal alloys such as high-speed steel, from which the cutting tools are manufactured.
Good morning, friends. Myself, Denson Francis. Roll number 21, S3 Mechanical. I am going to say about important alloy elements and their function. The elements are cobalt, silicon, and copper. Cobalt. The addition of cobalt increases heat and wear resistance. High cobalt alloy tool steels are best known for having excellent wear and corrosion resistance over a wide range of temperature. It also increases cutting efficiency and red hardness of tool steels. When subjected to strong radiation of nuclear reactor, cobalt becomes highly radioactive, and hence all stainless steels deployed in nuclear services will have certain cobalt limitation, often 0.2% at the most. This issue is important as some amount of remaining cobalt will be present in the nickel used to make austenitic stainless steels. Silicon. Silicon is typically employed as a deoxidizing agent in the steel melting process, as a small amount of silicon is used in most steels. It forms SiO2, silicon dioxide, and eliminates the presence of oxygen. As an alloying element, it is added in the range of 1.5 to 2.5% to improve strength and toughness. Silicon also increases magnetic permeability of steels used for transformers and motors, etc. For this purpose, silicon is added up to 5% in transformer steels. Copper. About 0.15 to 0.25% of copper is normally added to improve corrosion resistance. Presence of copper also promotes precipitation hardening and thereby higher strength and hardness. In stainless steel, copper is often present as a residual element. This element is added to several alloys to create precipitation, hardening characteristics, or to improve corrosion resistance, predominantly in sulfuric acid and seawater conditions. Thank you.
Good morning all, myself Basil Biju Roll number 18, S3 Mechanical. I am going to be taking a presentation on the topic important alloy elements and their functions. And the three important alloy elements that I am going to be taking the presentation on are lead, titanium, and sulfur. First, let's move on to lead. On its appearance, lead is a dull silver grey material. It is very soft and hence it can be easily worked into sheets. Lead is widely used for car batteries, pigments, ammunition, cable sheathing, weights for lifting, weight belts for diving, lead crystal allows radiation protection, and some solders. Since lead is a very soft material, it can be easily worked, and corrosion resistant metal has been used for pipes, pewter paint since Roman times. Lead is used for the manufacture of sheets, car batteries, pigments, and so on. In earlier times, it was used for pottery, insecticides, hair dyes, anti-knocking additive for petrol, and so on. However, all these uses have been discontinued now because lead is known to be detrimental to health, especially that of children. Now let's move on to the biological role of lead. Lead has no known biological role. However, it can accumulate in the body and cause serious health problems. It is toxic and carcinogenic, which means it can cause cancer. Now let's move on to the manufacturing of lead. Lead is chiefly obtained from mineral galena by a roasting process. At least 40% of lead in the UK, as per a survey, is recycled from secondary sources such as scrap, batteries, and pipes. Now let's move on to the second material, that is titanium. Titanium is a hard, shiny, and strong material. These alloys are mainly used in aircraft, spacecraft, and missiles because of their low density and their ability to withstand extremes of temperature. They are also used in golf clubs, laptops, bicycles, and crutches. Power plant users use titanium as condensers because of their resistance to corrosion. Titanium has also found surgical applications such as joint replacement, especially hip joints and tooth implants. Now let's move to the use of titanium, and the largest use of titanium is in the form of titanium 4 oxide. The biological role of titanium, just like lead, is very little. Titanium has no known biological role. However, titanium is also a carcinogenic compound. The manufacturing of titanium is by commercially reducing titanium chloride and magnesium. Titanium is also the ninth most abundant element on Earth, and it is almost always present in igneous rocks and the sediments derived from them. Now let's move on to the third material in our list, that is sulfur. There are several allotropes of sulfur. However, the most common form of sulfur is as yellow crystals. Let's move on to the uses of sulfur. Sulfur is used in the vulcanization of black rubber, as a fungicide, and in black gunpowder. Most sulfur is, however, used in the production of sulfuric acid, which is perhaps the most important chemical manufactured by Western civilizations. The most important of sulfuric acid many uses is the manufacture of phosphoric acid to make phosphate for fertilizers. Unlike lead and titanium, sulfur has a very essential biological role. Sulfur is essential to all living things. It is taken up as sulfate from the soil or seawater by plants and algae. Sulfur and sulfate are non-toxic. However, carbon disulfide, hydrogen disulfide, and sulfur dioxide all are toxic. Hydrogen sulfide is particularly dangerous and can cause death by diseases such as respiratory paralysis. Now let's move to the manufacturing of sulfur. Sulfur also occurs naturally as an element, often in volcanic areas. This has traditionally been a major source for human use. It is also widely found in many minerals, including iron pyrites, galena, gypsum, and Epsom salts. Modern sulfur production is almost entirely from various purification processes used to remove sulfur from natural gas, oil, and tar sands, and so on. Sulfur can also be obtained from unpurified fossil fuels by burning them. Sulfur dioxide, however, can enter the atmosphere, leading to an acid rain. Thank you.
Thank you, Basil. Myself, Aipadas, and today I'm going to talk about the important alloy elements: phosphorus, aluminium, and boron. Phosphorus. Phosphorus is a chemical element which has the symbol P and has an atomic number of 15. Elemental phosphorus exists in two major forms. These are white phosphorus and red phosphorus. Due to its high reactivity, phosphorus is never found as a free element on Earth. The concentration of phosphorus in the Earth's crust is about 1 gram per kilogram. In minerals, phosphorus generally exists as phosphate.
White phosphorus is the main component in flares and incendiary devices. Red phosphorus is a material which is found on the side of matchboxes, which is used to light the matches. The largest use of phosphorus compound is for making fertilizers. Phosphorus is also an important element in the production of steel. Phosphates are also used in the production of some detergents, but they are starting to restrict its use in some countries. This is because the use of phosphorus in detergents can lead to high phosphate levels in natural water supplies, causing unwanted algae to grow. Aluminium. Aluminium is a chemical element which is denoted by the symbol Al and has an atomic number 13. Aluminium appears as silvery white in color. It is a soft, non-magnetic and ductile metal in the boron group. Aluminium is the most abundant metal in the Earth's crust and the third most abundant element after oxygen and silicon. Bauxite is the chief ore of aluminium. Due to its high reactivity, native specimens of aluminium are very rare and limited to extreme reducing environments. Aluminium is known for its properties like low density and ability to resist corrosion through a phenomenon called passivation. Aluminium plays a role in electricity because of properties like Aluminium is used in electricity because it is relatively cheap, highly conductive, has enough mechanical strength and low density. It is also used in a wide range of household items from cooking utensils to furniture. Boron. Boron is a chemical element with the symbol B and has an atomic number of 5. It is a very low abundance element in the solar system and in the Earth's crust. It constitutes only about 0.001% by weight of Earth's crust. The most important compounds of boron are boric acid, borax, and boric oxide. These can be found in products like eye drops, mild antiseptics, etc. Boric oxide is a component which is commonly used in the manufacture of borosilicate glass. It makes the glass very tough and heat resistant. The isotope boron-10 is good at absorbing neutrons. This means it can be used to regulate nuclear reactors. Amorphous boron is a component which is used as a rocket fuel igniter. Since boron has a very low molecular weight and high energy of combustion, it makes it very suitable for use in rocket propellants. Thank you.